In this example, we have that a manufacturer is making open top boxes from rectangular sheets of cardboard by cutting equal squares on each side x that measure x from each corner and folding them upside. Now the volume of the box has been modeled by this function here. Now the domain is restricted by the cardboard dimensions, but the roots represent the values of x where the volume is equal to 0, meaning that you either cut the square too big or too small, and you don't end up with a box, or you end up with a box that has 0 volume, doesn't hold anything. We want to use the fact that when x is equal to 0 is one of the places where the volume is equal to 5. So in other words, if I cut a square that measures 5 by 5, what are the other sizes of squares that I can cut that's going to make this volume, this box, not have any volume? So we're going to figure this out by breaking this apart and creating a quadratic equation using division. So since x minus 5 is a solution, we're going to divide v of x, we're going to divide it by x minus a positive 5. And the technique we're going to use is synthetic division, so no long division here. So we're going to set this up. Trying to draw straight lines here. We're going to use 1, negative 12, 29, and 30. And the number, because we're using synthetic division, is going to be this value right here, 5. So we're going to bring down the 1, multiply that 1 with 5, and add these two numbers, which is going to be negative 6. We're going to multiply these two values, which is going to be negative 30. Sorry, this is 7. Negative 35, which is going to be negative 6, and then multiply that negative 6 with 5, which is negative 30, and 0. So we have x squared minus 7x minus 6, and we're going to see what makes this thing equal to 0. So let's see if we could do this by factorization. So we're going to break the x squared into factors of x and x. We have a negative sign in the middle, and since a negative times a negative is positive, that means that this factor is going to add something to that x. So let's see what options we have. Well, 6 has only 2 sets of factors, 1 and 6, 2 and 3. And none of those can give me that negative 6, because if I use 6 and 1, that doesn't work because one of them is negative and the other one is positive, so that's going to give me 5. This gives me negative 5, and if I do it the other way, that's going to just give me positive 5. So that does not work. But then neither does 2 or 3. In any combination, 3, 2, that doesn't add up to negative 7. That actually adds up to negative 1. And if I think, well, maybe I just need to switch them, that doesn't work either, because the larger factor always needs to go here, because this, regardless, is just going to just simply switch the sign and give me positive 1. So this doesn't work either. So what the heck? And none of the combinations of the factors of 6, in fact, give me, again, add up to give me that middle number. So what this means is that this is not factorable. So using this technique is going to be a waste of time. So let me scratch this out, and what we're going to do instead is use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c divided by 2a. So your example is going to be done the same way. You're not going to be able to factor this as the result, as the effect of this quadratic that we end up with is not factorable. So you're going to end up with the similar situation. So with the values of a, so let's continue. So with the values of a being 1, b being negative 7, and c being negative 3, we're going to plug it into our quadratic formula. So the negative of our b value is negative 7 plus or minus our b, which again is negative 7 to the second power, minus 4 times our value of a, which is 1, times our value of c, negative 6, is divide that by 2 times our value of a, which is 1. So let me highlight what I'm simplifying here. So first of all, that, this, and that. And let me do a different color. So let me do this in red. And I'll do this one in green. And I'll write those numbers in the corresponding value. So negative of negative 7 is going to be positive 7. We have plus or minus and the square root. Now plugging this into the Desmos calculator, this right here that I highlighted in red, not the square root, okay? Notice I have that symbol there, just the inside part. That gives us a total of 73. So I'm writing that in red. And then we're going to divide by 2 because 2 times 1 is 2. And let me color coordinate this, so that's going to be 2. So there's our 2 solutions. It doesn't look like it's 2 solutions, but it is because of that plus and minus symbol. So our 2 solutions are this. X, let me do it in black. X equals to 7 plus the square root of 73 divided by 2. And x also equals to 7 minus that square root of 73 divided by 2. So those other 2 places are again some exact values. So you have to cut it again the square like that and cut off a square those 2 sizes in order to end up with a volume of 0.